This video will show you how to solve equations with fractions. But first, let's review. Last year we learned about complex fractions and how they are related to dividing fractions. Here is an example of a complex fraction, 16/3 over 2/3. Remember that a complex fraction can have a fraction as a numerator or as a denominator, or both as a numerator and a denominator. So when I have 16/3 over 2/3, I know that is the same as 16/3 divided by, and I know I'm dividing because here I see my fraction bar. The fraction bar tells me to do the operation of division. So 16/3 divided by 2/3. So here I've written it vertically, but now I'm just writing it horizontally. So now I have a division problem, 16/3 divided by 2/3. When I divide, I know my rule is to keep, change, flip. So I keep my first fraction, which is 16/3. I change my division symbol to a multiplication symbol, and then I flip or take the reciprocal of my second fraction. So 2/3, when I take its reciprocal, is 3/2. So now I have a multiplication problem. I know that when I multiply fractions, I multiply the numerator times the numerator, and then the denominator times the denominator. So I know that 16 times 3 is 48, and I also know that 3 times 2 is 6. So 48/6 can be simplified. In other words, 48 divided by 6 is 8. So this is how complex fractions are related to dividing fractions. We'll need this skill to help us solve equations with fractions in them. So here's our first we do, solving a two-step equation with a fraction. So remember our checklist from previous videos. First we have to distribute if necessary. In this case, I see that I have to distribute because it's 2/3 times the quantity of x minus 2 is equal to 4. So I'm going to distribute the 2/3 to the x and then the 2/3 to that minus 2. I know that 2/3 times x is 2/3 x. And then I'm going to draw a squiggly line here and show my work off to the side. So now I have to do 2/3 times that minus 2 or times that negative 2. And I know that when I have a negative 2 or a whole number, well in this case an integer because it's negative, it's always over 1. So I have to make it into a fraction. And then I can just multiply. 2 times negative 2 I know is 4. 3 times 1 I know is 3. So this becomes 2/3 x minus 4/3, and then I bring down my equal sign, bring down my 4. So now I see that I have my coefficient, which is that 2/3, and I still have my constant, which is that minus 4/3. So I still have to use inverse operations to isolate x, so I'll add 4/3 to both sides. So on the left side, this cancels out, and I'm left with 2/3 x is equal to, then I'm going to jump again over to the right side here and show all of my work. So I'm really going to do 4 plus 4/3. So I know that, again, with a whole number or an integer, I'm going to put it over 1, so it's 4 over 1 plus 4/3. And so now I have to use my knowledge of adding fractions with unlike denominators. So I know that my least common denominator between 1 and 3 is 3. So 1 times 3 will give me 3, so 4 times 3 will give me 12. 3 times 1 will give me 3, so 4 times 1 will give me 4. And then I can add my numerators. 12 plus 4 I know is 16, so this becomes 16/3. So I jump back over here to my problem, so that's equal to 16/3. So now I have 2/3 x is equal to 16/3. So here on my left side, it's saying 2/3 times x, so I know the opposite of multiplication or times is division. So I'll divide both sides by my coefficient, which in this case is 2/3. So on my left side, these cancel out. I'm left with x. I'll bring down my equal sign. And then on the right side, I see that it's 16/3 divided by 2/3. That's a complex fraction. So it's the same as 16/3 divided by 2/3. And I know that's equal to 16/3 times 3/2. And so 16 times 3 I know is 48. 3 times 2 I know is 6. 48/6 is the same as 8, so x equals 8. And then to check to see if we're correct, you guys have access to your graphing calculators today. So wherever you see x in our original equation, you're going to plug in that 8. So once you plug in 8 and then work out the left side, it should equal 4 to know that we're correct. So now let's do an example of a multi-step equation with fractions. So here I have 2/3 x plus 6 is equal to 2/5 x plus 10. So again, with multi-step equations, I want to distribute if necessary. Here I don't have to because I don't see parentheses. And then I want to get all my variable terms on one side, my constants on the other side. So I'm going to start by subtracting 2/5 x from both sides. So on my right side, these will cancel out and I'm left with 10. Bring down my equal sign. So my left side, I have to now do this part, 2/3 x minus 2/5 x. So when we're subtracting these, I just want you to focus on the coefficients. So I'm going to draw my squiggly line and show my work off to the right side. So 2/3 minus 2/5. Now I have to use, again, my knowledge of subtracting fractions with unlike denominators. I know that the LCD between 3 and 5 is 15. So 3 times 5 will give me 15, so 2 times 5 will give me 10. 5 times 3 will give me 15, so 2 times 3 will give me 6. And then I can subtract, and I have 10 minus 6 is 4/15. So back to my problem over here, 2/3 x minus 2/5 x is 4/15 x. I'll bring down my plus 6. So again, I have to get x by itself, so then I'm going to subtract 6 from both sides. My left side, these cancel out, so I'm left with 4/15 x. Bring down my equal sign, 10 minus 6 I know is 4. So now I have 4/15 x is equal to 4, so I have to divide both sides by my coefficient, which is 4/15. On my left side, these will cancel out, so I have x is equal to 4 over 4/15. So this is a complex fraction, so I'm going to write it as 4 over 1. Remember, a whole number or an integer is always over 1. So 4 over 1 divided by 4/15 is the same as 4 over 1. I keep, change, and then flip. So then I multiply my fractions. 4 times 15 I know is 60, and then 1 times 4 I know is 4. 60/4, or in other words 60 divided by 4 I know is 15, so x equals 15. Again, use your calculator to plug in 15 into our original equation to double check that we are correct. The left side should equal the right side. So here are your first 3 practice problems. These are for solving two-step equations. So refer to the first we do as an example if you have questions. So complete these in your notebook and then jump back to the video to go through the answers together. So let's see how you did with the first one. 3/4 x plus 3 is equal to 9. So first I know I have to get rid of my constant by using inverse operations, so I'll subtract 3 from both sides. So on my left side I'm left with 3/4 x is equal to 9 minus 3 I know is 6. So now I have 3/4 x is equal to 6. I'm going to divide by my coefficient, so divide both sides by 3/4. On my left side I have x is equal to, and then on my right side I see it's 6 over 3/4, which is a complex fraction. So in other words, 6 over 1 divided by 3/4, and that's the same as 6 over 1 times 4/3, so I have to keep, change, flip. Then I can just multiply numerator times numerator, denominator times denominator. 6 times 4 is 24, 1 times 3 I know is 3. 24/3 simplified, in other words, is 24 divided by 3, which will give me 8, so x equals 8. And then let's see how you did with number 2. Negative 5 plus 1/2 x is equal to 15. Again, I have to get rid of my constant, so I'll add 5 to both sides because I see that it's starting as minus 5, so add 5 to both sides. And on the left side, I'm left with 1/2 x, bring down my equal sign. 15 plus 5 I know is 20. And then, so now I have to divide by my coefficient, so divide both sides by 1/2. On my left side, these will cancel out, so I'm left with x. And then on my right side, I have a complex fraction. 20 divided by 1/2 I know is the same as 20 over 1 times, 20 over 1 divided by 1/2, and that's equal to 20 over 1 times 2 over 1. So I multiply 20 times 2 I know is 40, 1 times 1 I know is 1. 40 over 1 is the same as 40, so x equals 40. And then let's see how you did with the third one. 2/3 times the quantity of x plus 5 is equal to 12. Here I know I have to distribute first because I see my parentheses, so I'm going to distribute the 2/3 to the x and to the 5. 2/3 times x I know is 2/3 x, and then 2/3 times the positive 5, so I'm going to show my work. So 2/3 times 5, so in other words, 2/3 times 5 over 1. So I multiply my numerators, 2 times 5 I know is 10, multiply my denominators, 3 times 1 is 3. So this becomes 2/3 x plus 10/3. Bring down my equal sign, bring down my 12. So now I have to get rid of my constant, so I subtract 10/3 from both sides. On my left side, I have 2/3 x remaining. Bring down my equal sign. On my right side here, I see that I have to do 12 minus 10/3, so I'm going to show my work over here. So it's the same as 12 over 1 minus 10/3. So I have to use my knowledge of subtracting fractions with unlike denominators. I know that my LCD between the 1 and the 3 is 3. So 1 times 3 will give me 3, so 12 times 3 will give me 36. 3 times 1 will give me 3, 10 times 1 will give me 10, and then I subtract. 36 minus 10 I know is 26, keep my denominator, so this becomes 26/3. So now I have 2/3 x is equal to 26/3. So then I divide both sides by my coefficient, which is 2/3. So on my left side I have x remaining, and then on my right side I see it's a complex fraction. So then I can do, let me erase this so I have space. So I can do 26/3 divided by 2/3. I know is the same as 26/3 times 3/2, and then I'll just write it underneath so I have room. I know that 26 times 3 is 78, and then 3 times 2 I know is 6. 78/6, if I simplify it, is the same as 78 divided by 6, which is 13. So here for number 3, x equals 13. So here are 3 more practice problems using, or 4 multi-step equations with fractions in them. So complete these in your notebook and then jump back to the video and we'll go over the steps and the answers.